Okay, let's wrap up section 4A from chapter 2. This will be the part 2 version. We went through this yesterday. And we're back to example 4. And this is a new type of problem for us, but I think it's going to be a pretty easy one for us to understand. I kind of like that the first one, I kind of like the way they're laid out in problems A and B, and you'll see what I'm talking about on that. Determine whether the curve has a tangent at the indicated point. I mean, how can it not have a tangent at some indicated point on a curve? Seems like it ought to have one anywhere. Well, the indicated point is at x equals 0. This is piecewise, and it gets interesting around 0. It changes. So is it pretty clear if this thing jumped? I mean, how in the world could we have a tangent? Oops, jumped from here. How can we have a tangent at that point? You know, the curve doesn't even continue. Let's take a look what happens here. Interested in around 0. Let's see. Okay, so I'm going to start here, and I'm going hunting at 0 with a circle. I put in 0, I get 2, 0, 0. With a circle, come on. So I got a circle there. And then I want to put some values that are less than, so I'm going to put in -1. When I put in -1, I get 2 plus 2 minus -1 squared 4 minus +1, 3. Can anyone tell me how I know that I just reached the vertex of this circle, or of this parabola, excuse me? That's it. That's the vertex. Other than I've done this problem 2 more times today, I still know. I knew then. Somebody got it last period. What do you think?
Is it because you move over 1 and up 1?
Yay, over 1 and up 1, and it's this is just a regular old parabola but upside down, right? And regular old parabolas move over 1, up 1. This one would move over 1, down 1. Now you can continue putting in more values, but we're going to get a point here, and we're going to be over 2, down 4. We're going to get a point here. This thing's going to look like that. Okay. And now I'm going to go to my second portion of the curve, which is just a line. I'm going to put in 0, hunting with a dot. 0. Okay, that's important. Fill in that circle, so it's a continuation. It's now continuous. So it's not a jump like over here. So maybe it does have a tangent line. Well, where does it go from there? Up 2 over 1. So we want the tangent line here. Well, I mean, that could be here, here, here. You know what I'm saying? How do we determine a tangent line? We took a dramatic turn. It didn't come down and like level off and go back up. It hit what's called a cusp. It just like bounced off of there. You with me? So this does not have a tangent at that point. Any other point on here, there's a tangent line to it, but not at that. And that is because at 0 there is a cusp. And that's what a cusp means. It's like you have to stop and go in a different direction. We can turn radically. We could come down, turn radically, and that's not a cusp. But as soon as I do something like that, or even, let's say I'm coming down at 20 degrees and I hit here and I turn to 19 degrees. I don't gradually do it. See what I'm saying? It's just a jerky turn. Okay. So there is no tangent there. Well, does that mean it seems like anytime I had a piecewise function, that would be the case. B. That is my segue. I'm interested around 2. So maybe I'll go over to 4. Don't think I need probably much more than that. Not interested in the whole graph, really. Let's go first function. I'm hunting at 2 with a dot. Very good, with a dot. Put in 2 and I get a half. A dot. I can be smaller than 2. Like 1. Put in 1 and I get 1. Put in a half and I get 2. Put in a third and I get 3. Get the picture of what's going on here? What happens to the left of there? You know what your answer should be? I don't care. Right? I don't care what happens. I care what happens at 2. That's what we're analyzing. Don't get hung up on the whole thing. I want to know what happens here. So I'm going to put 2 in. I'm hunting with a circle. Put in 2 and I get 4 minus 2. 2 on 4, 1/2. Okay, we got a chance. Put in 3. 3 gives me 1/4 down here. So this graph right now is doing that. Is that a cusp? I don't know. Or is it just a nice, smooth transition? Or is it like a sliding board? You're coming down with it, and then you put a plank in here, so bam, you hit just a little bit. Or you drop instantly. Or is it just a nice, smooth transition to that flat? It just came down and just continued on. What do we have to do? I need to find the slope of this at 2 and the slope of this at 2 and see if we have that perfect transition. I wouldn't have it here, right? I might have it here. So here I can't say, based on inspection, there's a cusp. But there could be a cusp here. Okay, so I'm going to find for f of x equals 1 on x. I'm going to find that guy's slope formula. Its slope at 2. So that is going to be the limit as h approaches 0 of f of x plus h. But this is a factor that puts things underneath 1. 1 on x plus h. Is that right? Minus f of x. 1 on x. 1, not x on x. 1 on x. All on h. Is that okay? Well, we've been here. Multiply by least common denominator, x plus h, on x plus h. Why can I do that? Because I'm multiplying by 1. Fancy form of 1. Who is my number 1 offender in this whole mess? That guy. As long as that guy's there as a factor, I got an issue. I need to cancel that factor. I'm not distributing that h in here. That guy's got to go. This h isn't even bad. I mean, if this is 0, no problem. 0 plus something else. So what do we get? Distribute the whole thing to here. The x plus h cancels. And I'm left with x. Minus. The x cancels. I'm left with 1 times x plus h. Make sure to distribute that negative. All on h times x plus h. Can I cancel my x plus h's? This one's good to go, not that one. That's just part of a term. It's not a factor of the top. So what happens? You know what's always going to happen if I do it right? Anything that doesn't have an h in it in the numerator is going to go away. I get an x. I get a minus x. They cancel, and what else do I get? A negative or a minus h. Very good. All on h, x plus h. Therefore, I can cancel this. I now have negative 1. Direct substitute 0. I've got negative 1 on x times x plus 0, or f prime of x is negative 1 on x squared. What do I care about? What am I finding? I'm finding the slope of this red curve. What do I care about? What's the slope at 2? So I want f prime of 2. That's negative 1 on x squared, or on 2 squared, excuse me, which is negative 1/4. slope equals negative 1/4. What about the blue curve? Oh, I guess I got to do that again with this function. Or do I? Isn't this just negative x on 4 plus 1? Isn't that just negative 1/4 x plus 1? I bet you the slope at that point on the blue curve is negative 1/4, since it's negative 1/4 everywhere, right? So the slope here is negative 1/4, which means sliding board coming down smooth. Coming down the sliding board, and it's nice and smooth. That's the way it should have been made. Therefore, what are we supposed to do? Determine if it has a tangent. Yes, it does, because the slopes match. If it does give its slope, got it. If I wanted the equation of the tangent line, I'd put in 2 here, and I'd get 1/2 out. 2 1/2 is on there, and I'd say it's y minus 1/2 equals negative 1/4 times x minus 2. And if I wanted the normal line, I'd say it's y minus 1/2 equals positive 4 times x minus 2. Is that okay? All right.